We've been spending a lot of time working on what we call direct methods of proof, and now we're going to look at indirect methods of proof. So first, we're going to review what a direct proof is. We're going to describe what indirect proofs are, and then we're going to give some examples of constructive and non-constructive proofs. So here is generally what a theorem looks like when we write stuff down. We assume some kind of assumptions, we then prove, or then we conclude some kind of conclusions. So that's what our theorems look like. And when we do this, or when we prove this for a direct proof, what we do is we assume exactly what is assumed in the theorem, we assume the assumptions, and then we show that the conclusions of the theorem are true when we assume the assumptions of the theorem. Indirect proofs are proofs where, well, we use any other proof method that is not direct. And so it may be hard to imagine what this is going to look like, but here are some of the things that can happen. We might assume things that are not assumed in the theorem for some reason. We might show things or prove things that are not conclusions of the theorem. But whatever we do in an indirect proof, the proof should still prove the original theorem. So I'm going to talk a little bit of constructive proofs versus non-constructive proofs to show you some of the indirect ways that we can prove things. So here's a theorem that says let f of x equal x squared minus 7x plus 6. Then we are going to prove there is a real number c such that f of c equals 0. And notice that we are proving a quantified statement, right? In fact, I think we called it existential. It's a there exists statement. There exists a real number c such that f of c equals 0. All right, so just a little side note. All right, so there are actually two different ways we can prove this theorem. One way is a constructive, and you might call it a direct way of proving things, and that is we actually find a number c that makes the theorem true. The theorem says there exists a number c such that f of c equals 0. If we actually find such a number c and show that it works, then that will prove the theorem. So if we were to guess x equals 1, we find f of 1. That gives us 1 squared minus 7 times 1 plus 6. And we do the arithmetic on that, and we get 0. Yay, that says f of 1 equals 0. That means there is a real number c, namely c equal to 1, such that f of c equals 0. And that is what we would call a constructive way of proving that theorem. But there are some non-constructive ways as well. And here's one possible way we can do this. So, I mean, we happen to just get lucky to find x equals 1 that works. But what we can, if we can't do that, if we couldn't do that, or for some reason we were having a bad day and couldn't find one, then we could still prove the existence indirectly. So what we might do is just, let's see what happens when we plug in x equals 0. So f of 0 equals 0 squared minus 7 times 0 plus 6 equals 6. Well, that doesn't work. 0 isn't a solution, but let's try something else. Let's see what happens when we do f of 2. Well, there we get 2 squared minus 7 times 2 plus 6, and if we do the simplifications on that, we get negative 4. So f of 0 is 6, f of 2 is negative 4. Who cares? Well, one of those happens to be positive, the output, and one of the outputs happens to be negative. That means that f of 0 is a positive number, f of 2 is a negative number, and since f is a continuous function, we're going to go back to calculus a little bit, the intermediate value theorem says, oh yeah, you remember that one? We had that one in calculus too. The intermediate value theorem says since there is one value that's positive, another one that's negative, that means there is some c between those inputs, between 0 and 2, such that f of c equals 0. Notice that we figured out there is a number without actually finding what the number is. So that's an example of a non-constructive way of proving things. We didn't actually find the number, we just showed indirectly that there is such a number. All right, so I want you to look at a couple of other examples in the in-class activities. The name of the PDF file is Indirect Proofs, and it is included with this video.